Greetings, dear parent. Thank you so much for tuning in. This is a pre-recorded parent webinar. Let me take this opportunity to introduce myself. I am Ms. Anjali and I'm a science teacher at WSF. I take science lessons for lower grades in the secondary school and chemistry lessons for the higher grades. And I shall be your host for today's webinar. Let's look into today's title of the webinar. The title is Science in the Secondary School, Teaching, Learning and the Curriculum. But before I kickstart with my presentation, I would like to talk about the current situation. Well, the current situation has forced many of us to adjust in far more drastic ways. I cannot believe in next 2 months, it's going to be 365 days of COVID-19. COVID-19 seems like a yesterday thing. It has changed the way we interact with people, the way we communicate, the way teaching is happening, the way learning is happening. It has changed everything. And we were not really ready for this kind of situation, this kind of living. But it's magical how we have adapted to the situation. There are few students who are trying to cope up with this new kind of learning, but at the same time, I have also seen students who have realized that independent way of learning is their way of learning. Whatever be the situation, we're trying to adapt and trying to make the best out of it. Hence, let's start with the presentation. So in my first slide, I have learning intention. Now, what do I mean by learning intention? Well, this is what I want you to know by the end of the webinar. So there are certain things that I want you to know after the webinar is over. And what are those things? Well, I want you to be able to explain how teaching and learning of science is taking place in WSF in the current situation. You should be able to list out the various online tools used at WSF to bring about engagement among the students. So, after my webinar is over, you should be able to tell somebody, if someone were to ask you, as to how teaching and learning is happening at WSF and what are the tools that they're using. So this is the learning intention for today. Here is a little snip of how my presentation will go. In the major chunk, I will be talking about the teaching and learning. So I will be speaking about the structure of every science lesson, as to how science lesson looks like. We will be talking about the digital tools that we're using in the classroom, given the fact that now some kids are completely 100% online, some kids are coming to school 100%, there's some kids who are like 50% online, 50%, I see them just on the alternate days. So what are the tools that are best suited for this particular situation, that is blended learning? We'll be looking into that bit. And towards the end, I'll be talking about the curriculum that is followed at WSF. So we will be looking into for grade 6 to 8, what curriculum are we following, and for grade 9 to 12. Yep, so this is what it is. Let's start with first the structure of science lesson. So every science lesson is structured in this way. Every science lesson that we take at WSF will have two things. The first thing, learning intention. I hope you noticed how when I started off with my webinar officially, I gave out the learning intention. I said, this is what I want you to learn for sure. Okay, so learning intention is basically a statement created by the teacher that describes clearly what the teacher wants the student to know by the end of the lesson. Because hey, you could attend my lesson, do a bit of things, but go back home not knowing what exactly I wanted you to know, right? So the teacher will definitely give out the learning intention before she starts off the lesson. Now, when we tell them, okay, this is what you're going to be learning, and the kids are learning, but how can they be sure that they have for real learned the stuff that we wanted them to? So in that case, the teacher will give out the success criteria. Success criteria, let's see what it is. It basically helps students know what success looks like. Because if you know how it looks like, what it looks like, you're more likely to achieve it. So when students know this, they're more likely to plan, predict, set goals, and acquire a sense of how to judge their own progress. So there you go. Every science lesson will be structured in this way. There will be a learning intention and there will be success criteria provided so that the students know what they're doing and how they're going to be achieving it. Out here, I have few snips of the science from different science lessons that have the learning intention mentioned and the success criteria. Let me take this one. Okay, let's see. So the teacher has put up 2 or 3 learning intentions. Now we usually stick to a number of 2 or 3 learning intentions. And the success criteria, okay, we start off by saying, I'm able to define the rate of a reaction. I am able to interpret the rate information from the graph for a reaction. I'm able to describe the experiments to investigate the effects of changes in temperature and surface area on the rate of reaction. So I don't know if you paid attention to this bit, but as I kept going from left to the right side, it became more and more complex. First, you just had to like define, then you had to describe, then you had to explain. It became a little more complex. And that's how it is for others as well. Because we are actually following Bloom's taxonomy for creating the success criteria. Now, what is Bloom's taxonomy? Bloom's taxonomy is a tool that we teachers are using so as to create the success criteria. It is a model which has levels, okay? Going from the bottom to the top, the level of complexity increases. Initially, we just want the kids to remember something, then remember or recall something, then understand, apply, analyze, evaluating, creating. As I go from bottom to the top, the complexity is increasing. The Bloom's taxonomy basically encourages students to have a higher thought process, higher order thinking process. That's what we want them to have. That's the reason, that's the whole agenda behind creating the success criteria and making it more and more complex. So there you go. The structure of science lesson is there will be learning intention, that's for sure mentioned, and success criteria as well. Now, once the teacher has given out that this is the learning intention, kids, this is what we're learning today, and you will get to know if you have understood or not by following the success criteria. She then gives a quick recap or a starter activity. Okay, here I have few snips. What do I mean by starter activity? We do not directly get into the lesson. We do like a little warm up. That's what I would say. Okay, let's look at this snip. Out here, the teacher has a quick recap. She's giving 3 minutes to kids and she's given certain questions. Probably she is going to be teaching something in today's lesson that is to be built up on what was taught in the last lesson. So she wants to build up the new concept from the previous one, but she also wants to know if the kids are able to, if they do remember and if they have any doubts or any queries. So hence she does a quick recap to set that tone for the lesson. Here then the teacher is saying, can you name some electrical appliances? Probably the teacher wants to talk about electricity, maybe. Here another picture and the teacher asks, identify the names of heat transfer methods. This is probably a quick recap sort of starter activity. So a starter activity is a short activity at the start of every session which engages your learners as soon as they arrive. It sets the tone of the session. So once the teacher gives the learning intention and success criteria, then there's a little starter activity to get the tone right, and then the teaching happens. So that's how it is. That's how the science lessons are structured at WSF. Now, what tools? But of course, right now, the teaching that we're doing is not the board one, not the normal PowerPoint presentation. I need some tools. So what online tools is WSF using for science? This kind of teaching that we're doing right now, well, nobody has really done before, ever. I mean, people have used online tools because it's fancy and it's nice, but using them exclusively as one of your mode of teaching, I don't think the world was really ready for it. So how do we know that if we really are doing the best job? Research can help you there. Research can find answers to things that are unknown. And so here I have a snip of an article from the Journal of Education and Practice. They've carried out a research, and let's see what the study recommends. The study recommends that science teachers need to consider various aspects to create an interactive online environment. Okay, they want us to create an interactive online environment, and how do we do it? So they need to use interactive tools such as PhET, interactive simulation, live worksheets, Nearpod, Kahoot, etc. Now out here, we have a little table which is talking about what are the best software and applications that can be used for teaching. There's so many of them, and this is the frequency, like how many times are they being used, how frequently are they being used. The ones that are highlighted are the ones that we are using in our science lessons. And since they have a high frequency, that means they're probably good. So we're pretty much on track to use the tools for best of the science teaching. Okay, so of all the 29 mentioned softwares, applications, websites, we're using these in our lessons, majorly these, to engage the learners. All of them are fantastic. Nearpod, one of my favorite. MS Teams is our main platform where we have our classes that are assigned to, they've been put in groups out there. PhET simulations, sciences, definitely we use this. In sciences, we definitely use this. Google Forms or Microsoft Forms, quizzes, Kahoot, YouTube, GCSE Pod. Now, in my next few slides, I'm going to give you a snip of few of these apps that we're using and give you a little brief information about it. I've also created, like in general, how I create lessons for my kids using these. I have created some for you to keep it interactive. Maybe you can, I'll be sharing out the links for these, and you can probably go and check out and see how it feels, see how your kids are learning science using these applications. Okay, let's start. So here we have first Nearpod. This one is one of my favorite. Nearpod is, how do I say it? Nearpod is an application where you create PowerPoint presentations and then you share that link. Like I have a link out here. Okay, I'll be sharing this out to you. You can go and check it out. It's really interactive. So the link is shared. Now I can decide if I want to keep the pace of the PowerPoint like student paced, or I decide if I want to switch the slides. And let's look at the first snip. Here, after my lesson was done, I gave the question like, what does electronic configuration mean to you? This PowerPoint, I let it be student paced. So there were a couple of questions. They would click on the right, the next question would come up. And while the kids are doing and typing in their answers, I out here, this is my screen. So I get an update. Okay, so this is what different kids think about that particular topic. And I get to know what is the participation percentage, what every kid is writing and thinking. Because online, when kids are online, not always can you hear them clearly. So this is faster and more efficient. I can get to understand the student participation that's happening. Now this is where Nearpod becomes my favorite. Out here, the kids had to draw the electrons. There's no way I can figure out what a kid is drawing back at home. I tried out the option of where I told the kid, okay, show me in your camera, what have you drawn? But because Wi-Fi, sometimes the connection is not very great, so you cannot see it very clearly. In that case, out here, Nearpod really helps because I can see what every kid is drawing, and once they submit, I can instantly give them the feedback, which is pretty fantastic. It helps me in planning out my lessons. I don't have to wait till they post their answers and then go home and check out. No, I can get a pretty much live update, and I can see how many of them are answering. So this is where Nearpod is fantastic. It basically helps teachers give instant feedback and also help to engage the learners, since we can't really see the work of the students at home. So this is one where I give the PowerPoint presentation to kids, and then they decide which slide, what do they want to answer. But at the same time, I can choose to decide the pace. I will share out the link, but I will not let them decide. And if I switch the slide, the next slide gets displayed. So it's fantastic. Everybody gets in to see the PowerPoint presentation in their own devices. This seems a magical app for me. Let's look at to the next application. We have quizzes. Now, this is majorly used again for formative assessment, and I have created another quiz for you. You can go and check out how this website looks like, how this application really is. Okay, so what we do is we have certain questions. Once the questions are answered by the kids, we get the reports, and in one shot, I get to see which kid has answered how many correct and how many incorrect. And accordingly, I can plan my lesson. Accordingly, I can understand, okay, my class does not like, let's see, springs. Okay, springs, the topic springs. We're talking about science spring for grade 6 was taken, and the accuracy is just 54%. So half of the class understands. Probably I need to replan my lesson. That's what that's the feedback that I get after I'm done with my lesson. So that's how quizzes is nicer with respect to formative assessment. Let's move next. Kahoot. Now, Kahoot is pretty much a favorite app for everybody. I've realized kids at WSF love Kahoot. Grade 6 loves it, grade 9, grade 10. Oh my God. This is also an app which is on the lines of quizzes, pretty much the same, but definitely more favorite one of kids. Next, MS Forms, Microsoft Forms. They're pretty basic forms, but they are very handy and helpful when it comes to assessment or home learning tasks, because I get to see how many people actually responded. 1, 2, I get to see on an average how much time they're actually taking to finish off that task. We in fact used Microsoft Forms as our assessment for carrying out the examinations for term 1. We're trying to incorporate this even more as home learning tasks, so that the kids get a hang of this app. But it's pretty simple. Most of them do get it. Okay, next is Microsoft Teams. Now, Microsoft Teams is like our home. It's our main platform, and it helps us to stay connected with our students, even during the lessons, of course, as live, but even after school hours. So kids do write in to ask, Miss, this is something that I don't understand. Can you take up in the next lesson? And so I can kind of put that doubt up in my lesson, and I don't have to wait, go to the lesson, and then the kid will ask me. It gives me a heads up. So in that way, well, that's how the online thing has become. So it's nothing new. But with respect to teaching, it never happened in the past. So this is, I find it pretty much fantastic. Yep. So this is Microsoft Teams, our main platform. Next, we have another app that we're using, Padlet. This is also a very, very great app. Now, how it works is I would give this towards the end. Let's say, okay, what did you learn from today's lesson? I want to know that. So you create a link. I've created one for you. maybe you just all you need to do is click on the link and just let me know if the webinar was good enough. Did you learn something out of it? Or in fact, what did you learn out of it? You can type in that, just like how your kids do it in the lessons out here. You can probably go and click on this and write, what did you learn from today from this webinar? Anyway, so how Padlet works is the kids click on the link, a wall is there, a wall is generated, that's what we call. Then there are these tabs, and then the kids write in whatever the teacher wants them to. So if I say, okay, what did you learn? They will just write that bit, and I can usually see every kid's name. Like this teacher, Miss Arushi, has given the topic metals and their properties, and then she's probably asked those kids to write what were the properties of the metals that they learned. And so the kids have written. So in one shot, I get to see what every kid is thinking. And accordingly, you can even give a feedback. Like out here again, Miss Arushi has used Padlet to probably do an assessment where she has, probably used it for some assessment form, and then she has liked if they were correct or incorrect accordingly. So this is also great, especially when we cannot use the strategy of exit slips, where we give them the slip and say, okay, you can only leave the lesson if you tell me what you've learned today, since we cannot exchange papers. So in that case, this is a good replacement. Now, finally, science is actually all about, oh no, okay, I think I'll have to move this aside. Okay, now science is at the end of the day all about practicals and doing experiments, but sadly we cannot do this for the safety reasons. And so how are we managing at WSF, keeping up doing of experiments and everything? Here is the PhET interactive simulation, the application that I talked about. Let me just write the name. Oh, that's a capital T. So we're using this. This was used, like in this picture, I don't know if you can see it very clearly. Let me just zoom in this then. Yeah. Okay, so there is a beaker and you're heating it up and you're putting in substances. What happens? Energy is given, temperature is increasing. You can either increase or make it go cold, so decreasing the temperature. The kids are exploring this side without actually doing the experiment. So this is fantastic. We're carrying out demonstrations in the lesson. This is for grade 11, rate of reaction. A demonstration was carried out. This is another demonstration. This was done for grade 6. The kids are doing by themselves, which is so cool. Yeah, so that's how we are trying to replace the individual practical work with making them still do the practical work, because safety restrictions, so these the safety restrictions replacing the individual practical work with interactive simulation and performing experiment at home. And this is how we are trying to keep up doing the experiments in such situation. Okay, what went well and even better if. If you have seen the assignments of your kids, this is something you would have seen. Not exactly what went well, but WWW and EBI. They are nothing but they are the assessment or feedback codes that we use at WSF. When I say WWI, what that means? Well, that basically means what went well. So these are the things that were good, great, or amazing, and things that they should continue doing. So when we, oh no, just keep this, right. So when we get some work that the kids have done, the assessment or feedback is given in this way. We will definitely tell them what went well. So basically, in short, saying that this was good, this is what you need to keep doing, okay, because it's fantastic. But at the same time, we will also tell them even better if. We would also tell them that things that they could do to improve. So what went well, we want more of this, and even better if you could do even more of this, then your work would be fantastic. This is how assessment codes are out here. Let me give you a few snips. So in general, the teacher will give out the www and will also mention the EBI. So as to improve the work of the child, and yeah, so that the person does, so that the child is improving and is able to achieve more. So here are a few snips of how we give the feedback, so as to keep it very, very specific. But the most that we want to focus on is self-assessment. You know, the kids are, we cannot do peer assessment, but we would love to do peer assessment. So how it works is we give them some work, okay? Instead of the teacher correcting, the peers exchange their work and then they correct out, point out what went well and what was incorrect and stuff. Of course, the teacher is guiding out here in this situation, but we cannot afford to do that right now. So we recommend and we focus majorly on self-assessment, that kids, once the work is assigned and everything, then the teacher discusses and the kids assess their own work and they take charge of their own learning and they become more and more independent. Because end of the day, the world wants you to be independent. You have to become independent. That's how we will survive. So we are trying to make our learners become more and more independent by taking charge of their learning and focusing on self-assessment, apart from the others. Okay, now this is something that I observed in the past 5 months of teaching. There's this one, the way the kids are taking down notes is so different. Initially, the teacher would dictate or teacher would write and they would take it down, or they would take their own running notes. But now some kids are getting their own devices and they don't want to write. They want to type it out. So here I'm going to show you a snip. This is from a grade 6 lesson. On the left-hand side, you can see here, okay, I'll give you a little prior information that's needed. This is basically the teacher was teaching that what are the components of blood, that in blood you have plasma, you have WBC, and then you have RBC. And then you will find, if you were to take a test tube and centrifuge it, you would find red blood cells at the bottom, then WBC, and then the plasma. So this is a kid that has drawn it, was preferring to handwrite the notes. And this kid has actually typed out everything, the learning intention and all of it, but this is so different, but has not drawn because he didn't have an option of drawing and he had to use the options or the tools that were available on Microsoft. And so this is what he has come up with, which I think was fantastic. I said, oh my God, for one work, you have 2 different perspectives. Kids are learning to adapt, and we're talking just grade 6. I thought this was really, really different, and you had to see it, that some kids are really getting a hang of this online learning and figuring out their own ways of how they would want to do their work. Very, very smart at such a young age. Right. Now, finally, let's just talk about the curriculum. We are kind of reaching towards the end. But when I say curriculum, what does that mean? What is exactly curriculum? So the term curriculum refers to the lessons and academic content that's taught in the school. As you are aware, WSF is a British school. And so the curriculum is organized into blocks of years called key stages. So in the secondary school, we have 3 key stages. We have key stage 3, where we're talking about grade 6, 7, and 8. We have key stage 9, key stage 4, where we're talking about grade 9 and 10, and then we have key stage 5, the higher grades. So this is your grade 6 to 8, this is your IGCSE grades, and this is your A-level grades. The key stage 3 is following the national curriculum for England, and we try to make our curriculum learning happen in such a way that it is suited for the learners, for our learners at our school. So, okay, here's the information that the curriculum, we have so many key stages. So you would now know if your kid is in grade 7, he's actually in key stage 3, and if your kid is in grade 10, he's in key stage 4, and if he's in 12, then he's in key stage 5. After every key stage, the kids get assessed. Okay, so now in key stage 3, when they are in grade 6, 7, and 8, we want our kids to achieve and learn in a better way, so that when they go to GCSE grades, they're actually sorted. They have achieved, or they have learned the things, and they are better ready to learn things in grade 9, 10. What I'm trying to say is, we want them to climb the ladder properly, climb the ladder in the most effective way, for which we have certain ladders that the students have to climb in every term. So let's assume if your kid is in grade 6, he would have roughly probably 6 to 7 ladders he has to climb. When I say ladders, what I mean is that he has to prove to the teacher that he has learned these concepts, and the teacher is going to assess him. So in term 1, he will have few ladders to climb, term 2, few more, and term 3, few more. And how are we exactly doing that? How am I figuring out or keeping a tab if the kid has actually climbed all the ladders? We're using an assessment system called learning ladders. The science department, in our science department, we have created certain ladders for every grade. This is for grade 6 to 8. Okay, that is key stage 3. We've created ladders, and every term we assess them, that have they, climbed that ladder or not. This is basically to make sure that they are ready before they move to key stage 4. Firstly, to make our teaching more effective. Secondly, so every grade will have ladders, and the students have to climb that ladder. There'll be ladders that are predefined by us for every term. Roughly 6 to 7 ladders every term. Now, once the kid then moves to key stage 4, so grade 9 and 10, then they have to write international GCSE. This is after they're done. After they're done with grade 9 and 10, then they write the international GCSE. Then they move on to key stage 5, do their studying bit out here, and then they write the A levels. Okay, so our focus is on enhancing their vocabulary, because when they enter this bit out here, they are choosing their own subjects. They are choosing whether they want to study biology or not. So the focus is enhancing their scientific vocabulary. So that's all bit about the curriculum. We have key stages. What examinations are they writing? When are they writing? How are we keeping a tab on the fact that they are learning and that they are growing using ladders? So let's see if you have learned something today. I hope by the end of this webinar, that is right now, you are able to list out the online tools that we are using at WSF for teaching science, and that you are able to describe how we are carrying out experiments at WSF, and that you are able to use your knowledge to describe how teaching and learning is taking place. So if someone were to ask you how teaching and learning of science is taking place at WSF, you will be in a state to answer that. So this is the end of the webinar. Thank you so much for tuning in. I hope you learned something, and this is me signing off. Thank you so much for your time.